To fix the runtime exception, we will use the Microsoft Dependency Injection Container built into ASP.NET Core. The Dependency Injection Container is configured when the application starts by registering services with it. We register application services with an iService collection. Any services that we expect to be injected at runtime must be registered with the iService collection. Failure to do so results in exceptions being thrown when those dependencies are first required, just as we saw in the example previously. In this demo, we'll register our first service with the Dependency Injection Container. If you use ASP.NET Core 5 and prior templates, it's worth highlighting that you configure services inside a class named Startup within its Configure Services method. This approach is still supported if you've upgraded a project to ASP.NET Core 6 and want to continue using that pattern. We're focusing on ASP.NET Core 6 in this course. Services are registered within the program.cs file. This file uses the C#9 feature called top-level statements and is the entry point for the application. The builder pattern is used with a web application builder, providing access for us to configure ASP.NET Core with services and the request pipeline. To register services, we access the iService collection from the builder. I like to add a local variable to simplify my service registrations, which I'll name services, and this will provide a shortcut to the iService collection. We will register services with this iService collection. Various extension methods exist to support different registration scenarios. To get us started, we'll use this overload of the add_transient extension method, accepting two generic arguments. The first generic argument is the abstract type, known as the service type. This is the type that dependent classes can expect to be injected by including it in their constructor parameters. The second generic argument is the implementation type, which is constrained such that it must inherit from and implement the service type. This method registers a service with a transient lifetime. I'll discuss service lifetimes in much greater detail in the Microsoft Dependency Injection Container module coming up. Until we fully understand the pros and cons of the different lifetimes, transient is a safe default for us to choose. The order of service registrations is generally not important. They can occur anywhere before build is called on the web application builder. One situation where order should be considered is if you find yourself registering multiple implementations of an interface. Now, we'll discuss this scenario in much more detail in the module called Registering More Complex Services. I prefer to register my application services before the framework and third-party services, so they're more visible at the beginning of the file. Let's register a service for the iWeather Forecaster interface. This is the type that we added to the index model constructor parameters. The implementation type in this case is going to be the concrete random weather forecaster type. The container will attempt to create and return an instance of this type when resolving a request for the iWeather Forecaster service type. This single line is all that's required to register a service, so we can go ahead and rerun the application. This time, no exception is thrown and the home page loads correctly. ASP.NET Core has activated the index model by resolving the required dependency from within the dependency injection container. I can hit F5 here to refresh this page several times, and each time the random weather forecaster returns a new random weather result.